Hey everyone, this is Belinda Carr. Welcome back to the Boost AEC podcast, where we dive into the world of construction and explore the stories of people and companies who are shaping the future of our industry. We've got yet another exciting podcast for you today. I'm speaking with Roger Krulak, founder and CEO of FullStack Modular. Thanks for joining us, Roger.
Well, Belinda, thank you so much for the invitation.
So your company, FullStack Modular, designs, manufactures, and builds mid and high-rise modular buildings. Is that a pretty good overview of your company?
I mean, that is our primary focus on the majority of what we do. And yes, we are specifically focused on the sort of anything you can't build out of standard wood stick built construction. So 7 stories and up.
Got it. And where's your company located?
So we have our headquarters now in Hamden, Connecticut, which is very close to New Haven, and then we have a factory in Portland, Oregon.
All right, and you all have several office locations too, because I know you have a presence in California.
Yeah. We're building right now for California in Portland, Oregon.
And when did you start the company, and what was your main motivation behind starting FullStack Modular?
Yeah, so I it's a good question. I started the company while I was working at Force City, and we started what was at that time called FCS Modular, and in that process, we're designing and then ultimately built the tallest modular building in the world. And while that was happening, Force City became a real estate investment trust, sold off many of their assets, and I raised money with some investors and bought the company from them, and then stayed located with that intellectual property that we created and the team that built that.
And what was the tallest modular building?
So at that point it was 33 stories, and it's still the tallest modular building in the United States. It is not the tallest in the world anymore. There are many, not many, a handful of others that are taller.
Got it. Okay. I guess let's dive into the details of your company. Y'all have a really well built out website, and you talk about the design, manufacturing, and the construction process. Let's talk a little bit more about that. Seems like you all have developed a proprietary software for the design phase of these modular buildings.
Yeah, I mean, I think it's important to identify that it's really 2 things. It's very much a process. So what has evolved is that in order to use a system, our way of building buildings is a system. It's a structural system, it's a mechanical system, electrical, plumbing system, and the fully integrated SMEP solution that is created in segments, in mods, basically. And so in order to do that, those are parameters that need to be incorporated at the early design stage. So what we do is we have a process whereby we work with generally local architects or design architects, and they have to agree and effectively utilize our system and our parameters to make the design process effective. So that's really what it is. And yes, we have parametric software that helps you, ideate enough so that you can figure out what's going on without having to go into a full design process. And all of our processes are integrated design processes. So, the mechanical, electrical, and structural engineering is part of the early schematic process. So we can come up with engineered schematics that utilize our system and also effectively create the built environment that the developer is trying to achieve.
So you talked about working really closely with architects in the early stages. Is your software a plugin for Revit, or is it a standalone software?
It's standalone. We do have some Revit information obviously available, but it is it is a sort of a parametric process that's outside of Revit.
So does that work in parallel? Because I know architects, and we're also reliant on the Autodesk Construction Cloud. So how does that work? Do architects do the initial design in Revit, export it to your software, and then your team kind of takes over and bounces ideas back to the architect?
Such a good question. I mean, basically what happens generally is that we will provide, during the engineered schematic phase, we will provide structural, sort of modular box details that the architect can be building off of. And then obviously there are MEP add-ins and other things for distribution, but it all starts with
Yeah.
to keep everything in the box. Everybody says think outside the box. We think the exact opposite.
Oh,
We want it all to be in one place, organized, distributed, coordinated. That's the advantage, right? If you're going to build a building in the theoretical in a factory, so you're not building it in its final resting place. You're building it in a theoretical location, and so all of that needs to be fully coordinated, clash detected, organized, and that's where we work. We do early design with the architects to make sure that SMEP coordination is part of the process.
I want to stick with this design aspect of it because we all know that that is an extremely critical phase. Something goes wrong over here, you miss something, and then it has a ripple effect throughout the rest of the construction timeline. I noticed that your boxes, your modules, also are fully complete. Like you all have interior fit outs, cabinetry, even exterior cladding. All of that is built in the factory and incorporated into the modules and then shipped to the job site. How are y'all able to figure out something as complex as facades or even bring in an interior designer so early on into the design stage?
Yeah, such a good question. It's honestly not that complicated as long as you're willing to embrace
Just
something
finding
we
the right people to work with, is
well,
it?
no, no, because as an industry, and it's not all the industry's fault. A lot of it is the money that's been, driven into the industry and the process by which we currently design buildings. And if you look at a set of design drawings from the 50s, or if you look at a set of design drawings today, you're going to find a wide variety of mostly differential. There is far less information in sort of the design drawings that you would normally see issued for a permit today than there would be in the 50s, where everything is very detailed. So we've moved away from, for a whole bunch of reasons, we've moved away from the absolutely coordinated solutions until well past the time when you're sort of in production, as it is, or construction. If you're building in the theoretical, that's an impossibility, right? Because we're only building, you can't see how everything is relating. You only know theoretically how everything is relating because they're not touching each other. They're not sitting on top of each other. They're not. So to your point, what the process allows is definitive, absolute placement of every system and its associated pieces and parts, and their coordinated interface with all of the other, structural, mechanical, electrical, plumbing, facade, because it has to match theoretical. If it doesn't match theoretical, the building's not going to go together.
Yeah. Well, there's another side to this. There's another stakeholder that we haven't talked about, and it's the client. Now,
Yeah.
I've talked to a lot of people in the modular offsite prefab industry, and they talk about, and I side with the client in this aspect. Clients need their thumbprint on their project because it's a sense of pride. There's a lot of money and effort and all the stuff and resources being put into this project. How do you and your team provide that uniqueness or the thumbprint to a prefabricated modular building?
Yeah. So what is different about us in many ways is that we have a system by which we create modular multifamily buildings. And there is also tremendous adaptability, flexibility in what it is that we're actually building within certain parameters. So say, for instance, a market apartment in Minneapolis, Minnesota is going to have way different parameters than a high-end hotel in downtown San Francisco. And so the cladding's likely different. The size of the rooms is likely different. The location of many of the amenities is likely different. And our system is very flexible, while understanding that it depends on what your goals are. If your goals are build it as fast as possible, make it absolutely perfect, and I don't care what it costs, but I don't want to disrupt the neighborhood, and I don't want to have to deal with the traffic, etc. That's one set of parameters. If the other parameter is I want it to be cost effective as possible, I want to optimize the design for efficiency, and the market needs this, then it's a whole other set of parameters. So you can drive the end result with our system to meet the parametric needs of what it is. And so once the owner is willing to identify what those are, the old adage of, good, cheap, and quick, choose any two, right? So
I was
not
just thinking
exactly
that.
Yeah, not exactly that, but similar. And so, yes, you decide the amount of variability will greatly sort of diminish the economies of scale, but may be valuable for that particular project. So we can't ignore that.
That's right. Yeah. So let's move on to the second part of of your process, which is the manufacturing part. And you said you have two plants, one in Connecticut and one on the West Coast.
Yeah.
What does the manufacturing look like? Is it an assembly line where you all deal with modules at a time, or are you all making all these components and they're ready and then they're being used whenever they're needed?
Yeah, great question. So we don't have exactly what you would call in manufacturing a single piece workflow of, cars being, but what we do have is we do have assemblies, and we have sub-assemblies and then sub-assemblies. So it is organized as a manufacturing process, and there are work centers that produce specific products for those uses and then assemble them much like you would a car. So imagine, like the engine is in one place and the windshield's in another place and the bathroom pod's in one place and the walls are in another place, and then they all get assembled and then facade installed, and then, then they're coordinated, organized, mate line connection pieces installed, and then wrapped and sent out ready for.
And what percentage do you estimate is the manufacturing automated, and what percentage is good old manual labor?
Yeah, it's well, first of all, no matter what, it's automated, right? I mean, regardless of whether you have a robot or not, the reality is that our system there's these walls that are being produced this way, that gets organized and assembled into wall panels, that gets organized and assembled into the subcomponents of the building, that gets organized into. So it is a completely automated and integrated process, and all of that provides and creates code that can be communicated to anything, a robot, a person, or anything in between, CNC machine. So we have, I would say we're on the low spectrum of roboticized, and we're on the sort of mid spectrum of automation.
Got it. Okay. So it sounds like there's a mix of you all using robot arms and
Exactly.
CNC machines and using manual labor.
Right.
And your team, how do you all identify inefficiencies in either side, either the manual labor or the robotic aspects of it, and say, okay, maybe it's time to switch. Maybe we need to take a different approach. Are there metrics that you all are constantly collecting?
Sure. So we like many sort of lean manufacturing, MMC, there's a tack time analysis that says our expectations are going to be that we're going to finish this in 5 hours with 3 people. And if we're taking 10 hours, and we're consistently taking 10 hours, no matter how much we organize the people, no matter how much we organize the drawings, then we have a drag on our completion schedule, and then we can adjust should we. By the way, I have to say this because I am very opinionated about it. If you bought a robot and it's not efficient, you went about it the completely wrong way. Like, the robot should be the last. Like, automation is a long spectrum of processes before you get to say, like, I'm going to have Joe Robot do this thing. Because until you actually know how to do it, and until you know how to describe to a robot in code how to do it, it's not going to work, right? And then once you know how to do it, once you got it, down pat, then there's an opportunity for many things to be automated.
That's fascinating. Like I already said, I've talked to different people, and everyone seems to have a different approach to modular construction. Like, I've talked to a particular group in Idaho, and I've visited their factory, and they went the route of trying to automate everything from the earlier stage. And there was obviously an enormous amount of investment put into the company, but they said, this is the route that we want to take. And there's another company I talked to just 2 weeks ago, I think I published a podcast with them called Bot Build. They took the a different path, like kind of like what you're talking about,
Yeah.
a more mixed approach, only
Yep.
buying secondhand robots when it was absolutely necessary. And
I know
it's
them.
just
I know them both.
fascinating. Yeah, it's just fascinating to see all these companies approaching this problem of, or this act of modular construction in such different ways.
Yeah. I think it's probably worth noting, and to your point, that the value proposition of building, a building in pieces offsite is frankly mostly a labor. It's a labor calc, right? So the idea is if you can decrease the amount of labor cost on a per item basis, you have the ability to drive construction costs down. Material costs, there's some optimization, there's something on the margin, but at the end of the day, whatever you're producing, labor is going to be somewhere between 20 and 40% of your cost, right? And if you can increase productivity by 3x, there's a value proposition. And there's no textbook or workbook on how to do that, right? You could take sort of Six Sigma classes and do pull plans for construction process. You could get marginal increases and decreases, but there's no playbook for that. So yes, it is. But I do actually, I stand by exactly what I said, even though I know both of those people, and I agree, and I think they agree with me. You need to know what you're doing in order to teach a robot how to do it. So, and if you buy robots ahead of time, well, and you have that much money, I hope it all works out. Oftentimes it hasn't, and if you look at history, like it's not. There's a bunch of sort of graveyard factories
Yeah.
that spent a little bit too much on robots before they knew exactly what they were doing. At the same time, there is no question that the ability to increase productivity on a per person basis or decrease labor cost using automation is definitive.
Yeah. So do you see your company have you already seen it like constantly evolving? Like while you're on the lookout for inefficiencies within your company, but you're also on the lookout for the latest robots out there that could, because it's constantly changing. Every single week there's a new robot arm coming out, new tooling, new software, all that stuff. So you have to keep an eye on all of that, because even though it is expensive and like you said, it has to be taken as a last resort, that new thing could change to transform your business.
So I think the answer to that question is that the idea of manufacturing as opposed to construction is continuous improvement, right? Mm-hmm. So every time we do something, we look at it and we shift. I mean, our original system for building this building from 2012 and 13, we're in version 5.0. Probably by next week, we'll be at 6.0. And that includes everything you're talking about. But not only that, like, for instance, I mean, we're talking construction, like we have found a faster way to install floor and ceiling joists just by thinking about how we automate the process for manufacturing the chassis. And so now, instead of it taking 19 hours with a crew of 4, it takes 2, and no robots, it's just thinking about the intelligence of the automation and the design for manufacturing process that outlines how it happens. As an example, I mean, I've got a bunch of examples. So my answer to your question is, yes, we are looking at what robots are out there, but we're also looking at what processes. Yeah. Like, the interesting thing about a factory is because you're in a factory, you can utilize things that's very hard to use on a construction site, right? You're basically not climbing up anything. You're not taking lifts. You can integrate machinery or methodologies that are very complicated to do on site that are super easy to do in a factory. And that is also part of the quotient that provides productivity.
Your company, we talked about it being around for the last 8 years or so. That is a long time, and it's truly impressive, because we've seen, like you said, the graveyard in the offsite modular industry is pretty extensive. What has kept you going, you and your company going? How have you been different than all these other companies that unfortunately failed?
Yeah. So I think there's a couple of things. I mean, luck is always part of it. Our timing is good. We were able to pivot during COVID in a way that worked and made us, survive. We don't have massive amounts of investment. I mean, when you have massive amounts of investment, you have to provide massive amounts of return. So we have been, although we've done, the tallest modular building in the world, and we're working on huge projects, we're not. My wife, who I quote often, would say, it's super hard to boil the ocean. And a lot of the people who have failed, we're trying to boil the ocean. Like, I'm solving all these problems.
Let's use humanoid robots to put up the panels.
Exactly. So, yeah, forget humans. We're just going to do this all in an AI platform and just rock'em sock'em robot manufacturing. And by the way, that is going to continue to evolve. And I do believe that is a way to efficient labor costs and intelligent manufacturing and all of those things. At the same time, we spent a lot of time and our real focus on two major things. One of them is, how does our system work? Like, does it work efficiently? And can we deliver a quality product working efficiently in a safe fashion that is productive, first of all? And then how does that system both interface with the existing conditions on site? So what do we do for that? And also, how do we take enough scope so that the on-site work is predictable and costable? Because mostly what happens is you have a manufactured product that may be excellent, but the problem is that the on-site work to install it is not definable, and the risk associated with that for the general contractor, et cetera, is high enough that you really don't get much cost benefit because it gets swallowed up by the risks. So we spent a lot of time, how do we minimize the quantity of work? How do we identify the quantity of work, and how do we describe it and provide information so that the on-site work that's happening is definable? Because that's where it gets lost. And then on top of that, our system is completely integrated. So we spent a lot of time on that. So you just give us something to sit on, and the mods are everything from that point through the parapet. So it's all one thing. We don't need concrete cores. We don't need hallways installed. Everything is fully distributed in our system, which is significantly different than pretty much anyone out there.
It is, yeah.
And I think it's so while everybody's been trying to figure out how to build it faster now, we've been trying to how to build it right, and then focus on the automation. And I think that at least today, I think that's been a good road and a good process. And we have found as a result of that our system is seismically responsive. It's responsive to heavy wind. It's responsive to heavy snow loads, and it's very adaptable because it thought about all of those things in the process.
So I spoke to one of the companies that I've spoken to, modular companies. They said it only makes sense financially for them to accept projects in California, even because they're located in Idaho. And that goes back to the labor costs that you were talking about earlier. How have y'all overcome that hurdle?
Yeah, so I don't know that. So I think what they're saying, and I know who you're talking about. So I think what they're saying, because I know many of them, is that in places where the cost of construction is high, the potential relative difference is also high. And so in dense urban environments, in the Los Angeleses, in the San Franciscos, in the New Yorks, in the Bostons of the world, of the country, that's where the variance in construction costs is much higher than they would be, say, for instance, in Iowa, right? And so our system is very much, the product is very focused on that dense urban environment. We're born out of New York, right? So we're very focused on the mid to high rise anyway. So we tend to look at those areas for that reason. But it is true that the variance between, in construction costs there, say, as opposed to, frankly, Atlanta's catching up, but there's a, Raleigh's even started to catch up on the construction cost. But yes, when there's a larger VIG, there's a larger opportunity for sale.
Is there a particular, you've been in the industry for a long time now, is there a particular project that comes to mind that really stands out over others? Was maybe because of a hurdle that you all overcame that really changed the direction of your company, or in a positive way, like the client feedback that you got made you reinforce the belief in your company that what y'all are doing is right? Y'all are transforming the AEC industry in the right way.
Yeah. Yeah, I mean, I think some of the stuff I can't announce yet, but we've been chosen for a lot of RFPs. But we've also won a lot of RFPs and REIs in the space, both in New York and elsewhere in California. And I think the reason, well, I know that the reason is because of the system and that what we've created, and our ability to think about that as applications. For instance, in COVID, we built a bunch of hospital mods and restaurant mods, which is normally not our process, but
that's what you meant by pivoting during COVID.
Right. So what happened is, okay, nobody was building buildings at that time. You couldn't even get permits to build them. The building departments were closed down. What are we going to do? And at the same time, I was hearing like restaurants are going to close because they don't have anywhere to feed people, and we have huge, emergency room, lack of emergency room availability. So I'm like, okay, look, we could use our technology to adapt to something that is valuable. And now there's all these companies that have restaurant mods you could buy, and we made them. We made a bunch of them, but it's not really our business, but it was. And the medical stuff, is still being sort of adapted today. So I feel good about our company's ability to understand what fits within our system and utilize it to benefit the end user.
Do you see a difference in acceptance over the last 5 to 6 years or so compared to early on in FullStack Modular's life?
I mean, look, I'm going to use a lot of adages, but necessity is the mother of invention, right? I mean, so the interesting thing that's happened, of course, it's been good for modular for sure, is that interest rates have climbed, right? So the cost of money was close to zero for a long time. And so it didn't matter whether you finished this year, unless you're a hotel operator and you had sort of like some huge, it didn't matter if it was finished this year or next year or the year after. You had a little bit of taxes to pay, but there really wasn't much. Now, if you're building a building and it takes 2.5 years to finish, you're paying a lot of interest. So now they're thinking about speed as a cost, because for a long time, modular said really the only thing you can gain, and that was for the reasons I was telling you about earlier, is you can gain speed, but you're not going to save much money. And part of the reason you're not going to save money is because you can't really define what the on-site scope is. It all fits together. But that's so yes, there is a huge need. And frankly, we all know developers at the end of the day are asking for it, because they're like, I can't do this anymore. I can't have construction overruns, lack of certainty. And the role that the developers as a group had in it, they're not going to take responsibility for it, because it wasn't them individually, but the way the AEC industry has evolved, as we talked about, is do as little work as possible, because developers don't need to pay much money for design if it's not really a design yet. And then when you get the job, give it to the electrical company and they'll engineer it. And then hopefully they won't fight too much about the mechanical engineer who's engineering the other part. You're laughing because you know that that's exactly what happens, right? So like, we don't do that. We can't do that. I mean, all the workers at FullStack Modular work for FullStack Modular. I mean, we have some partners that we are partners with that make chassis, that make facades, but everything's done in the factory, so it's fully coordinated, and you can't have a theoretical drawing that doesn't match the building, because you can't fix that problem. Well, you can. It's a mess. I mean, I've seen it happen, not so much in our buildings, but I've seen it happen around the country, and it's scary. When your core is 4 feet off of the mods that are built, that's a problem, right? It can be fixed. It's messy, and that's obviously that's at the extreme. There's obviously less complicated things. If the mechanical systems don't pop out where they're supposed to, and you're trying to interface with it, et cetera, et cetera.
Yeah,
Yeah.
lots of issues that can arise if you
Yeah.
don't anticipate, or at least try to anticipate them as much as you can in the early stages. So I have to ask you, what are your future plans for the business? So congratulations on expanding to the West Coast, but
Yeah.
do
Super
you
exciting.
have any plans on expanding somewhere else?
Lots to come. I mean, our biggest pivot that we are working on right now is pivoting so that we can be partners in developing our own projects so that we can
Wow.
drive this efficiently. And that we can help the developer that we're partnering with get here and get efficient. We really don't do any projects that aren't design build anymore. They have to be. It doesn't really, we call it design manufacture construct, which you sort of it has to be that way because you really can't modularize a conventional building and start it all over again unless it's just not working, and then you could start all over again. But that's a big cost and a big time. So we are moving our scope into sort of the both the design, manufacture, construct, and develop side of it, so that we can be helpful in that space.
Got it. Well, I have one last question for you. Thank you so much for sharing all this information. But one last question, and I try to ask all my interviewees, podcast guests this. What advice would you have for a young professional who's coming into the AEC industry and is really passionate about offsite modular construction? Like you, they've noticed that this is the right way, or one of the right ways that the industry needs to head. What advice would you have for them?
Yeah. So I would say it's a way, because I think there's lots of ways.
Yes.
I don't think, this is not the solution for everything. Everything can't be modular effectively. Everything could be modular, but it shouldn't necessarily. But what I would say is take the chances, get some experience, live, apply yourself to opportunities that allow you to be exposed to this so that you can learn about where your skills best fit into the process. And that's, whether that's internships or, going to some place that may not be the perfect job, but you think that they're doing something that you think you could learn from, or find a mentor, just like any other career. Like, find somebody who you really want to learn from and spend the time and energy to learn from them, and it will take you far, and your career will evolve. The industry is growing. There aren't any employees pretty much in any industry that are needed. So, if you're passionate about it, fantastic. And the industry is growing and the opportunities are significant. So, hop on board. It's far more logical. At the end of the day, it's so much work up front, but at the end of the day, once it starts moving, it's a pretty simple process.
Yeah. Well, you made the entire process seem very simple, but I know you and your team have probably gone through hell and come back and gone through lots of failures to get where you are.
I didn't say it was easy, but once the design is done, once the production drawings are finished, that's where all the work is.
Yeah.
Like, honestly, running a factory isn't that complicated. I mean, to be fair, but preparing the systems to run a factory and be able to manage both the human resources and the physical resources and the machinery and all those things is super complicated. But the actual day-to-day, once you've got that organized, pretty simple, right?
Yeah.
The value proposition is being able to take less skilled workforce and do highly technical, capable, efficient processes that create the built environment.
Yeah. Well, that's true. But thank you so much for your advice and for sharing your story. I'm looking forward to seeing where FullStack Modular heads and how it changes our industry. Again, thanks, Roger, for being a guest on our podcast.
Thank you, Belinda. I really appreciate the opportunity.